All right, good afternoon, everyone, and thank you for joining us for the fifth and final session of this series to do a wrap up on instructional routines brought to you by the BCAMT. And we've really enjoyed bringing this series to you, and we've got some ideas for next year. We'd like to get your feedback as well, and that'll come at the end. I will get us going here with an activity, and just have to share my screen. Okay. There we go. I'm just going to move the chat there so I have it. Okay. So first, I'd like to acknowledge that I work, learn, and play on the unceded shared territories of the Coast Salish. My work is in Surrey, and I acknowledge the Kaitsi-Semiahmoo and Kwantlen First Nations who have been stewards on this land since time immemorial. And of course, special attention still as we reel and deal with the horrible truth that came out of Kamloops, and working together to try to develop a better understanding and become action-oriented more so going forward. We are going to start with a routine that we have not done with you yet. If you remember, if you were part of the very first set of workshops or any of the workshops that we've done, there's been a lot of routines. There are so many more that we could get to. So we're going to do a couple tonight that we haven't done yet. The first one will be fairly quick just to get us engaged and thinking mathematically. Some of you may be familiar with it already, but I wanted to make sure that we at least covered it. It's called SPLAT, and SPLAT is something that was imagined and brought to life by Steve Wyborny. Steve is, oh gosh, is it Oregon? I think pretty sure he's from Oregon, if not Washington State. He's often a part of our conferences when we have the Northwest Conference. Speaking of which, the Northwest Conference, we should have thrown in a promo here that the Northwest Conference will be going ahead, but the news about the stages of reopening were just not confident enough to be able to do a face-to-face conference. So the Northwest Conference is going to be virtual. So sorry that we will not be going up to Whistler as we had hoped this fall. However, I am excited to let you know that our fall conference the year after in 2022, which would normally just be in the Lower Mainland somewhere, we have decided to do that face-to-face in Whistler. So stay tuned for some more announcements regarding the details of that. Back to SPLAT. So SPLAT, there's a number of different things that go on with SPLAT, but just to get it starts with a number talk image. So here are a certain number of counters, and I'd like you to just pause and think, how many do you see and how do you see them? Okay, and I won't wait for a response on this, or we won't worry about getting interactive with this. Of course, in a class we would. The answer is 14, and you might have some discussion about what you see. Perhaps you saw groups of 4. I see 3 groups of 4, and then 2 more kind of stuck there right in the middle. Perhaps you saw 2 groups of 4 and a group of 6. A number of different ways of seeing the 14. So at this point, it's just a number talk image. But now comes the SPLAT. There we go. Wow, that was delayed. That was a very slow SPLAT. That was SPLAT without the exclamation point. Normally it's SPLAT with an exclamation point. Okay, there's a SPLAT. And so now the idea about SPLAT is that each SPLAT covers the same number of counters. So we know that there are 14 altogether. We know that each SPLAT covers the same number of counters. So the question becomes, how many are behind each SPLAT, and how do we know? So I will pause my voice there for a moment and let you think about that. And I realize this may not be a big challenge for you, but I'd still like you to think about what students might think as they make sense of what could be the number behind each splat. So feel free, I won't even wait, feel free to type a response in the chat or feel free to unmute yourself. Okay, thank you, Julie and A Younger and Richard. So yeah, so both of our all of these responses are looking at in relationship to the number 14 in slightly different ways. And this is what's nice about doing routines, is that you can get similar ideas expressed in different ways. We see 3 groups. We know that there are 14 altogether and 2 showing, so that means that 12 are hidden. So in order to have the 12 hidden under 3 groups, then under each one must be a group of 4. And as Richard points out, we could use for equations, and notice that something like solving 3n plus 2 equals 14 is a grade 7 level equation. And yet this routine could be done even with primary students who have no sense yet of variables or solving equations like that, a 2-step equation, because it's just about the algebraic thinking, and students can still reason about this. So we don't need to get into, oh, I have to subtract 2 from both sides and then divide both sides by 3. That just kind of that process gets in the way of the sense we can make of this situation, where we're just reasoning to how we can build a number using parts and leftovers. So the splat routines are number, at the face of it, they look like number routines, but at its foundation, they're also great for building some algebraic reasoning. So I'm going to show you 2 or 3 other kinds of splats just to give you a sense. Because on Steve Wyborny's site, he's got tons of different kinds. This is sort of a level 2 kind of splat where it's called a multi-splat. And they get more advanced. So for example, so here's a number. And we could reason to see in different ways how there are 15 there altogether. And in this time, the splats come like this. Oh, that was more like a splat, came sooner. So in this case, the splats are different colors. And the idea with splats of different colors is that they cover a different amount. So if splats are the same color, they cover the same amount. If splats are a different color, they color a different amount. Now, if we started here, or we don't remember what was covered, what do we know about what's under these splats? What is left uncovered is independent of what's covered. All we do know about what's covered is that under each splat, there are 2 different ones. So this idea of recognizing, okay, 10 are covered, and they are covered under 2 different splats. So if this were a regular multi-splat, we would say there has to be 5 under each. But this time, they're different. And we know that they come close to 10. So I see Richard's thinking there, the dots were fairly even distributed. So when we think about this particular case, it's likely 6 and 4, but reasoning, yes, I agree with you, Julie, it would not be 5 and 5. But so there are some combinations of 10 that make sense here. So even, grade 1 students who are making sense of 10, even kindergarten students making sense of 10 can reason to this. But notice that what it's actually doing here is a relationship. There's a relationship between the green and yellow. And this is a relationship, again, it's not just the foundation of algebra from an equation solving side, it's a foundation of algebra from the relations side. So there's actually a function that could relate the green to the yellow. That's a great question, Julie, whether we'd start with them uncovered and then covered. So there's another kind of splat, which I'll show in a moment, where you do start with it covered. It really just depends. I think once kids are either older or more experienced, what you don't want is for them to just try to remember, oh, how many dots did I see there, and try to figure out how many were covered then. You want them to kind of use this as, oh, pretend I forgot what it looked like beforehand. That's a good comment as well, Tammy, that in this case, we're representing different amounts using different colors instead of different sizes. So there would be a way to adapt this if you'd rather make size a difference. That way there'd still be a relationship in terms of which one is bigger or smaller. By the way, we're doing this virtually, and that's the way the activities are put together. He's got them as a whole set of PowerPoint files. He's also got Google Slide versions, which are still PowerPoint, but the animations are set to work in Google Slides. But I've seen teachers actually cut out and make these splat things using felt or some kind of material to cover physical counters and or magnetic splats and do a kind of show and share in that way. So in this particular case, I could reveal one of them, and then once we see one of them, we can reason to the other. So this is a kind where we start with it covered, and then we think about how many could there be? So just in the interest of time, I'll kind of just say what's sort of behind using it this kind of way is it's a kind of relationship. So 1, 2, 3, 4, we know that there are 4 uncovered and that they're the same number each one. So there could be 4, there could be 7, there could be 10, 13, and so on. So now it's a case of building a growing pattern or a linear relationship, depending upon the grade level. So once again, a different kind of algebraic thinking. And once I reveal that there are 5, then we can reason that there are 19 here altogether. There are also some fraction splats, which are nice even at that first stage of figuring out how many are there, which in this case is 5, covering a splat, and then actually reasoning, how do I build 5 if I only have 2 and 1 more third? And thinking about, okay, I need 2 more holes, and then I need to finish off what was missing from that 1/3. So there's a whole set of fraction splats as well. So if you're not familiar with splat, go to stevewhiteborney.com. He's got tons of other great routines there. It's kind of organized in a blog format, so you can always search through his site, or he's always got, the ones that are most popular and so on. So it's very easy to find. But Steve is great at building a lot of things to share with all teachers. So with that, I'm going to leave splat behind and pass it over to Amanda.
There we go. So in our wrap-up session, we just thought it would be nice if we had an opportunity to reflect on all of the learning that we did, but then also take a moment to think about what our next steps might be. And so this is another routine. It's a thinking routine. So it comes from the work of Ron Richard. So if you ever wanted to use a kind of thinking routine, you could just Google thinking routines and you can find a whole bunch of them. They come from Project Zero out of Harvard. And so this thinking routine is called Claim Support Question. And so we're just going to take a moment to think about or to make a claim about using instructional routines in your practice. So this might be something that you saw in your students. It might be something that you saw in yourself. So a claim. And then we're going to identify some support for our claim. So things that we saw, things that we were feeling, things that we know that are going to support that claim. Why did we say that in the first place? And then a question. So what's left hanging, what hasn't been explained, or what new learning is required based on that claim to move us forward. So something simple might be, my claim is that I really noticed that it took a little bit of time for my students to get the hang of it. My support for that was, oh my gosh, we were all over the place when we first started. And so my students really didn't know what kinds of things to say for things that might be the same or different, because maybe they didn't have the language, but then as we did it over and over again, they got a little bit more comfortable with it. And so my question moving forward might be something like, how can I now use those thinking routines to be really tightly connected to the content that I'm teaching at the time? So that's kind of an example. Mark, next slide. So there's a bit.ly at the bottom. We're going to put you in breakout groups, and we can use that code. I'm going to throw it into the chat so that we can see it when it goes off of this screen. But we're going to use that, and what comes up if we click that is a Google Doc. And so it's a way for us to kind of see everybody's learning and what their next steps are. So in our breakout groups, one thing that's really important also is that we don't all start at the top. If we can kind of space ourselves out. This is that moment where if you're a teacher, maybe you'd be using like vertical whiteboards, and so you could see all the students working in the spaces. But this is my little whiteboards that I'm using in the group. So we can see everybody's thinking, and we can track that information, and hopefully moving forward, we can take some of those questions and help you connect you and to provide some support for those questions that you have moving forward. So Mark's going to throw us into some breakout groups. Look at the magic is happening behind the scenes. And then we're just going to talk really quickly in a small group and just record our thinking about what is that thing that you saw in yourself or in your students. Why did you say that? What's your support? And then what's your question moving forward?
Okay, well, look at how full this document is. That's really great to be able to capture that. And of course, that link will remain active, so you can always come back and look at it. We'll probably include the link when we're building a website that has sort of all the key links to the different parts of this series, and as well as the videos and the slides and things like that as well. Okay, back to, here we go. Okay, so one more routine, just to finish this off. It's a fairly recent routine. I guess it's been out for a few years now, but Nat Banting out of Saskatchewan, what he started to do, and he spoke a little bit about this at the closing keynote at the Northwest back in 2018, where he says, there's a lot of rich math that can come out of opening up the mathematics, opening up the restrictions, so that gives a lot of students flexibility and different entryways and so on. But he talked about how you can push mathematical thinking without taking away those entry points by bringing in some constraints, so kind of going the other way. So that's sort of what's behind Menu Math. We're going to do an example that was created by Chad Williams, and there's a bunch of activities there that across all different grade levels that are on that Banting site. And we're going to do one because of our K-12 audience that's about building some triangles. So in a moment, I'm going to show you some constraints. And I want you to think about some triangles that meet each constraint. So just look at each constraint separately and just kind of think about what kind of triangles you could make for each one. And I'll give about a minute of you just to think about that. Okay, so you'll notice that for each one is kind of its own very open-ended question. You know, build a triangle that has a right angle or has a perimeter greater than 12. And there are so many different possibilities there. So there's an entryway for all students here. A student could look at these 6 clues and come up with 6 different triangles. But the way that the constraints push the mathematical thinking further is by trying to think of what is the fewest number of triangles that it would take in order to satisfy all these constraints. So in order to do this live with you, I've decided to put these constraints into Desmos and create a place where you can sketch. And so there will be a code to join. But before we do that, I will show you what it looks like, just in case any of you have not gone into a Desmos activity before. So in a moment in the chat, I am going to paste a link. And once you get there, if you have a Desmos account, great, you can sign in, but you don't need to sign in. And I'd rather you not take the time right now to create an account if you don't have one. So I'm just going to go continue without signing in, and then I will create a name. And you can put whatever name you like because you're not my classroom. I don't need to go back and check with you about any of your responses. And but I will just put my name in there for now. Okay, then it leads to a screen like this. So there you see on the right, these are the constraints. And on the left is the sketch area. So I can draw sketches here. I'm going to undo that because that's not going to be very helpful for doing a triangle. So what I'd like you to do is really think about what are the fewest number of triangles that you could do, and then draw a sketch of them. So don't draw them too big so that you can fit them all in. And I'm just looking at the first one because I'm not really thinking about trying to meet any of the other constraints yet. So I'm just going to draw a right triangle there. And now I could draw another triangle, and what you're trying to do is try to draw as few triangles as possible. So I'm going to put the link in here now so you can go there. And we'll take at least 5 minutes or so just to see what you can come up with. Okay, I see people joining. Let me know in the chat if you have any issues. So I'll give you one more minute and then I will pause the activity. Okay, with apologies who are still scribing, I'm now going to pause it and invite you back to your Zoom window, and we can take a look at some of the responses. Okay, I realize with more time, then more people could complete some things. What I will do, notice that in Desmos, I have the ability to see everybody's screens. Right now, I've anonymized it so that we see the names of mathematicians and scientists rather than actual individual students. And what I like about some of these responses here is that without prompting, they started to put the letters in that showed which ones were satisfied. So let's take a look at a couple which are similar here. I'm going to take a couple of snapshots there, and I'll go up to my snapshots here and put them in, and we can see well, how are they similar? How are they different? So here are two different responses, and we can see they both use letters to show their comparisons. Their triangles look an awful lot alike. Some of the measurements are a little bit different, and some show specificity. Is that the word? I can never get that word right. Some used words to describe, but there's a lot going on here that we can look at and have some classroom discussion around. The idea here with looking at all these different constraints as well is, so the goal is to try to find as few, and it looks like the fewest that anybody found was 3, and we can have some discussion around why that is. Ultimately, it comes down to, which clues can work well together. So, and which clues cannot work well together. So another thing I could do in Desmos, I could have done a card sort and had all the clues there on cards, and then you could kind of group the clues that you think go well together and the clues that that need to be separated out, and kind of build it that way. So here was a sketch area where you could do it visually, and then I could do another one where we're physically just drawing those clues together. So it's a great kind of routine. It pushes the thinking to really try to think strategically, to try to get to that goal of using as few as possible. Anyway, we still have Janice who's going to talk to us for a little bit, and then some closure with Sue. So I'm going to go back to the slides here, and I will pass it over to Janice.
Great, Mark, will you navigate the slides for me?
Yes, I will.
Thank you. So just as sort of, hello everyone, I'm just joining late here on this session. As we're coming to the end of this series, we thought we would share some ways that teachers who have been using instructional routines for a while, sort of what their thinking is and how they incorporate them into their already existing math programming. So I think one of the main reasons, as I'm hoping that you've heard throughout the different sessions, is that instructional routines are just this lovely way to build a math community as a whole class. And it's the routines are inclusive. They have access points for all students, and they're just, the low floor, high ceiling type of routine. Also developing discourse, an ability to talk about math in different ways, listen to each other, build on each other's thinking, explain, justify, all those things that are embedded in our curricular competencies. And also opportunities for small group instruction routines. Again, once students feel confident with the expectations of a routine, that can transfer to other types of learning experiences as well. Many of our teachers begin with 1 or 2 routines at the beginning of the year. And our district has been using routines for probably about 7 or 8 years, pretty consistently now, beginning with a couple routines at the beginning of the year and build their repertoire over time. And students learn to see how so many of these routines are quite similar in terms of expectations. Some of our teachers, even teachers who've been using routines for many years, still have some sort of set routines that they use all year. So every Wednesday is a WODB Wednesday. And, the students know when they come into math class or the time of day for math that they're going to begin with a WODB. And it may not be connected to their lesson. It may be just, as an instructional routine to bring the class together and talk about and do math together. And then as teachers begin more familiarity and comfort with routines, they start to use them as an intentional part of their planning. And that's sort of what I'm going to share in the next couple of slides, is how you sort of weave those in and choose routines based on what you're doing. Mark, can you move it ahead? So I'm going to share a primary week plan and an intermediate week plan, because those are the ones I've collaborated with on teachers in my district, where teachers have intentionally chosen routines that align with whatever big idea or concept that they're working on for that week. So beginning with that big idea or concept in mind and the competencies that help support that, and then working backwards and thinking, what kinds of learning experiences can we provide for students to help develop that big idea, those competencies, and that understanding of a math concept. Sometimes, again, the routine might just sort of stand on its own as the beginning of a lesson or the end of a lesson or at another part of the day, but other times it segues into a more fulsome type of lesson. So Mark, if you can forward again, and I'll just sort of go over, this was a primary week. The class had been working on number, and the big ideas around numbers represent quantity, and then beginning to think about using decomposing as an idea to help students understand addition and subtraction strategies. And so we began the week in community, reading a story together and having students do some math while the story was being read, and talking about math, again, building community. And then as an example, on that day, they took, after that book, they did a Marion Small type open question, focusing on decomposing quantities, and shared their thinking. And then building on that, because the first day had really been focusing on decomposing, but thinking about part-whole relationships for addition, we began with the math routine splat. So again, that was very intentionally chosen because it was building on this idea of decomposing and composing quantities and the different relationships. And then in this classroom, and in many of our primary classrooms, 2 or 3 times a week, there's a math workshop time where students are doing and practicing math, solving problems, doing tasks. And they have some choices around that. All the tasks or problems are around the same big idea or concept. And so they're all practicing the same thing, but might be doing it in different ways. And then the debrief afterwards has students share what they did. But you can see how, we did the instructional routine of splat all together. And then when we went into math workshop time, doing splat was a opportunity or a choice for the students to continue to play with that routine and practice the mathematics that's embedded in that. And so having individual splat mats and some materials that students could use, or using digital tools as well for that. On the Wednesday, it was investigating with materials, and then using decomposing as that big concept as students investigated materials. And then Thursday opened up with another math routine. And I don't think we did quick images in this series, but that's another very well-known routine. It's in both of Jessica Shumway's books, Number Sense Routines. And so using 10 frames as a structure is really sort of a benchmark number to think about addition strategies at grade 1 and grade 2. So just doing quick images with 10 frames to begin. And then again, you can see how in the math workshop, those opportunity students have to learn are connected to that idea of using a 10 frame. Also in the math workshop time, the teacher's working with a small group and rotating small groups and doing little mini number talks with students focusing on addition strategies with decomposing. And again, that leads into Friday, where as a whole class, we begin with a number talk. So students have had a chance to practice those strategies a little bit and share their strategies during the small group work. And then as a whole class doing the number talk routine to open the Friday. And the intermediate example on the next slide, Mark, is essentially the same kind of structure. And many of our teachers are planning in this way now, where they do something, starting the week of doing the math and talking about the math together, and then doing some practice and then coming back together. And then again, looking at these routines. So this is a grade 4 and 5. It was 2 classes, and they were developing, the range of understandings around fractions over a few weeks, and this was just 1 week. So again, we intentionally chose a fraction talk. We intentionally chose clothesline and ordering fractions, and then adding decimal numbers and equivalent fractions to Friday's math routine around clothesline. And then you can see how those routines are also embedded in the math workshop time as well. So just a couple of examples of how teachers are intentionally choosing routines that connect to the big ideas and concepts and competencies that they're developing for and planning during a week. Thanks.
Thank you, Janice. Now for closure, I know that Sue got kicked out, but I believe she's back. And so we're going to wrap things up with Sue.
So we're almost out of time here, which is great because I haven't planned much for my wrap up, other than to say really thank you. It's been really interesting being part of these webinars over the course of this year and seeing the same names showing up and having chances to talk with different people from all over the place. It's been actually kind of the most energizing part of my week some days. Because things are feeling so isolated in my situation here in my classroom. And so thank you so much for joining us, kind of month after month. And we've seen people sort of join us for the instructional routine series. There's been a couple of different assessment series, and we hope to continue these webinars next year. And so we can see that this is a really easy way to reach out and talk to people without having to incur costs of travel, and just have these quick little sessions on a regular basis so that we can continue to support you and work with one another as we move forward. Still really looking forward to meeting up in person. A little sad that we won't be at Whistler in October, but pretty excited that we get to plan a conference in Whistler in 2022. So we will definitely all be ready to be in Whistler a year from October. I have put a bit.ly URL up here, and I've just put together a quick survey so that as we start to think about next year, we might be able to make some plans about what would work for teachers. And so we did tend to do these on Wednesdays, and we always started them at 3:30, but maybe there are people out there that 3:30 just doesn't work for. And so I'm hoping that you guys will take a few minutes to fill out this survey, whether you do it now or some other time over the next couple of days, so that we can use your feedback as we move forward and plan sessions for next year. If anyone has any questions or comments that you want to add in here, feel free to unmute yourself. I see some things coming through the comments.
I do just want to say that the Northwest Conference didn't go away. That we are offering the Northwest Conference. It's just going to be through a virtual platform. So that conference is coming at you in the fall. So if you do want to continue this learning, definitely in October, we're going to have a full program there. We've got some great speakers lined up. And so we would like to see you at that virtual conference in October, and then also again in October of 2022 in Whistler.
I had a couple of people ask me if we're still doing the Northwest.
Sorry, I didn't
Alright.
mean to make it sound like we weren't meeting in October.
It's not the same, but it's still meeting.
Yes,
We
All right,
have
I'm
great,
gonna-
there are great speakers.
yes.
It is going to be a great conference. And
Okay.
people all over the place are going to be attending because it's going to be virtual.
That's true. That's true.
See?
All right. Thank you to those who took the time to write a nice comment in the chat at the end. That's wonderful. I really appreciate that. A lot of times it's just like a great, thanks, bye kind of message, and so it's nice with full understanding to Adam. I know what he feels, so that's his thank you's okay. But the survey would be great. I've reposted the link in the chat, and we look forward to when and however our paths may cross to come, especially into next year.